another episode of the Jarring Science Club. I'm your host, Brenda, and in today's experiment, we're going to be learning about how currents move in the ocean. Today I have my daughter Amy playing with me in the room, and so you may hear her in the background. Here's what you need. A large jar, the larger the better. I'm trying to mimic an ocean. A blue ice cube. I've pre-made mine here. A jar that you will put hot water in, and some red food coloring to dye your hot water. All right, let's get started. All right, guys, here is our jar ocean, and we have our blue ice cube and our hot red water here. So first we're going to add our blue ice, a little bit of blue water, and there it is, kind of dispersing in there. Now let's add the hot water in. See, it disperses much faster. And now let's watch as they move and change how the water moves in the jar. Let's add a bit more cold, a little more hot. Now our currents are moving. I wanted to zoom in a little closer so you could see how the water is moving. And see, it's trying to combine, the cold and the hot's trying to combine, making a purple. But you can literally see how the water is moving, just like it does in the ocean because of temperature changes. And you can keep repeating this as long as you have cold water and hot water and you want to refresh the ocean water. You can do it as many times as you want. It's always fun. You can also see how the hot water is kind of settling on the top and the cold water is kind of settling on the bottom. Just like it does in the ocean, the deeper you get, the colder it gets. Here's the science. Today you made a currents jar, where we learned a little bit how currents work in the ocean. What causes a current has several different factors, but one of the biggest contributing factors to a current is the different temperature levels in the ocean. Some areas of the ocean are hot, some areas are cold, and depending on where those are, the temperature of the water can pull or push water around to make the currents. Hot water moves faster than cold water because warm molecules move faster than cold molecules. This means that in the ocean, warmer water is going to move faster than cooler water. However, molecules like to stabilize and become one solid temperature. So when you have a warm bit of water and a cold bit of water that then combine, they will move the water in different speeds to create a current of consistently temperatured water. That's it for today. See you next time.